Okay, in this video tutorial, I'm going to show you step by step how I bring in an image sequence which I've converted from a movie file, track it, export the FBX, then bring it into Maya. Okay, so that I can bring in the exact movement that I've tracked in Fusion Studio. Then once I've rendered this sequence, then I bring it back into Fusion again. Okay, and I'll also be talking about another type of match moving solve. Alright, so let's get started. Start a new project, and then I'm going to bring in my sequence. I'm going to click on the loader and go to the folder containing the sequence that I'm going to use. So this sequence was shot on the Blackmagic Ursa Mini camera. And here's the sequence. I already converted it into an image sequence, which is the EXR. So to do that, you just need to load up the clip and then connect it to a saver and then save it as a EXR sequence. So I'll not be demonstrating that. So I already converted this into an image sequence. So altogether there are 251 frames, including frame 0. I'm going to change the frame range of the timeline here to match the clip length. So I'm going to double click this and change it to 250, so that the time ruler reflects 251 frames, including frame 0. So the next step I want to do is to apply a little bit of lens undistort. So press Ctrl Spacebar, then search for lens, then you will find the lens distort. Okay, if you have the loader, the sequence selected, it will automatically be linked to your node. And then you want to go to the inspector, go over to the lens distortion model drop down, and then we just want to adjust the lens distortion a little bit. I'm going to scrub the timeline to find an area which I can find a straight line. I think the beginning is just fine. Okay, there's not much distortion on this clip itself, but we are still going to give it a little bit of undistort. So in order to preview the effect of the lens distort node, we need to click on the node itself and drag it to the second viewer so that we can see the effect of the lens distort node. Alright, so let me just adjust the values here again. So if you want to do a fine adjustment, hold down to the control key, left mouse click on the numbers, and as you adjust, you can control the amount of undistort on the edge of the screen, edge of the clip itself. So I'm just going, actually this one is too much, I'm going to go back to the default, and I'm just basically going to distort this until I get this edge here as straight as possible. So usually I will just give it a very small value. Okay, I don't want to overdo this, otherwise later when we do the camera tracking, it's going to introduce errors. Alright, so I think this looks good enough for me. Okay, I'm just eyeballing this. Okay, normally most of the lens, right, in major studios, right, will have the lens calibrated for the distortion. Okay, so I'll now bring in the camera tracker. So press Ctrl Spacebar, bring in the camera tracker. So type CTR. So remember, the camera tracker is only if you're using the DaVinci Resolve version of Fusion, the camera tracker is only available in the studio version. Now of course there's no free version of Fusion 16, so Fusion Studio naturally comes with the camera tracker. So now we're going to view what the camera tracker is seeing. So you can just click on the node and drag it to the viewer. So now we're looking at what the camera tracker is seeing. So we're just going to use the default to track the features on this shot. So I'm going to enable preview, and I'm just going to scrub through the timeline just to make sure that there's a good spread of features that are being detected. Now you can play with the detection threshold and minimum features separation. Okay, so I think this is a good spread. in the interest of time, I'm not going to use bidirectional, and the gutter size, I'm just going to reduce it so that I have more features on the edges that are being searched. So for the new track defaults, we're going to use the optical flow, and we're just going to keep everything at default, and then we're just going to hit auto track. So when I shot this clip here, I made sure that there's plenty of lighting and there's plenty of features on the frame itself, so that when I'm able to track this in the tracker, you'll be able to solve this quite easily. Now, if there are people walking around, or if there are objects that are moving, okay, you will have to apply a mask to actually mask them out. Okay, you can apply a polygon mask to mask it out, and the mask can be actually connected over to the camera tracker here. And of course, you have to animate the mask to block out any moving objects. So you want to track features that are stationary, that are not moving at all, so that the camera tracker is able to create that 3D space. Also, if your camera has movement that's moving forward or sideways, then that will have enough parallax information for the camera tracker to recreate the 3D space. Okay, so now we're reaching 250 frames, and then I can move on to the next stage. Okay, I'm going to leave everything at default. I actually used the Ursa Mini to shoot this, so I'm going to keep it at this settings. I'm not going to touch the focal length, so I'm going to go to the solve straight away, and I'm just going to hit solve. So the tracker has detected about 1,688 points, so there's plenty of points to track. So I think generally this shot will take about 13 seconds, or around 13 seconds to solve, and then we get a solve error of 0.336, which is very, very good. Alright, so anything that is under 1 or anything under 0.7 will be very good. So 0.368 pixels is pretty good. Okay, so there are some yellow points, no red points, no red tracker points. So I'm just gonna ignore this, and I'm happy with the tracker. So I can now start to align the layout. Now, the camera tracker for Fusion in the export has an export tab. Now I'm not going to use the export tab. I'm going to use a slightly different workflow here. I'm going to change this to a single viewer, and I'm going to create a merge 3D node. So press Control Space Bar, create a merge 3D node. Select the merge 3D, which is the shortcut is 3mg, and then add it out. Now you notice that even though I select and I create the node, it will not connect because there are two different type of outputs from the camera tracker. So you do not want to use the image output here. You want to use the scene output, drag it, and then connect it to the merge 3D. Click on the merge 3D node and then drag it on top so that you are seeing the output of the camera tracker. Holding down the control, middle mouse roll out to zoom out, and you can see the camera and the point cloud, or the locator cloud, is created for you in 3D space. And if you zoom in, holding down the control, middle mouse roll in, you can see the green trajectory that is being created. Alright, so you can see that the camera motion is replicated. Okay, right now we're in a perspective 3D view in the merge 3D node. So to tumble the view, you hold down to Alt and middle mouse click to tumble, and you can see that the 3D space is generally created very well. Now the condition for this type of solve, in order to see this clearly, like right now I can see that this is the ground, and these points are basically the tree, the bushes, the leaves, and then the path of this walkway here. It's managed. The tracker managed to replicate the 3D space very, very well. However, you can see that the orientation is still not lined up yet. So you can see that this is if you look at the grid here, this grid represents the 3D grid of the Fusion compositor. All right. So we need to get these group of tracker points, you can see here, if I look at the side, when I tumble the view to look at the side, you'll notice that they all form a flat plane. So we are I'm pretty sure that these are actually the ground plane. Okay, so let's take a look at through the camera. So to look through the camera, you move your cursor over to the lower left hand side corner. Now to pan, you just middle mouse click and drag. You can see at the lower right here there's perspective. If you right mouse click on this symbol here, you can change the view to the camera. So right now we are viewing through the camera. Now you notice that the locators are way too big, so to reduce the size of the locator, we're going to click on the camera tracker node, go over to the fourth tab and reduce the locator size. Just bring it down until they become like dots. Alright, so now you can see very clearly, okay, you can see that the world grid is obviously not lined up with the floor grid, so we need to do a little bit of orientation. Okay, so to help the camera tracker to reorient the cameras, we can click back on the camera tracker and this time go over to the fourth export tab. Now we're not going to export anything from here because we're going to change the workflow a little bit. So go to the 3D scene transform. We are going to do the lineup so that these group of points, right, will be lined up with the grid points. So currently we have not done the alignment yet. The default setting is always set to align. So we're going to switch this off to underline. Alright, so now we're going to tell the camera tracker that these points are on a flat plane. So you can hold down to the shift key and you can select the points that you know definitely are on a flat plane. So I'm selecting all these locator points. Selecting all these locator points. And then I'm going to the orientation, and then I'm going to specify by clicking on this button, set from selection, meaning that these locator points which I've selected, now you want to add to selections, you just hold on to shift and then drag a box to select them. So the default is XZ plane. Okay, we know that XZ is the X orientation and the Z orientation. Y is always pointing up to the sky. So it is oriented to the ground. So now we go and click on set from selection and click. Well, nothing has happened yet because we need to switch this back to align, right? But that's fine and all. Now we need to select one point to specify the origin. Now before we do that, let's try switching this back to align and let's see what happens. I'm going to click on aligned. All right, and now you see that the grid has started or seems to be lined up with the ground plane. All right, or the ground in the plate itself, in the video plate. So I'm going to switch over to the perspective view, and I'm going to zoom out, holding down to Control, middle mouse, roll out, and holding down to Alt, middle mouse, click and drag to tumble, to pan, and then Control, middle mouse, roll in to zoom in again. Okay, right now I need to zoom into the shot. Okay, let me just reset the view a bit again. Okay, so you can see that although the ground plane, which you can see from these dots here, are now lined up flat, but it is not sticking onto the grid. That's because we have not set our origin point yet. So let's go back to underline again, and we're going to switch back to our camera view. So right mouse click on this icon and go to the camera view, and I'm going to click on one point or any of the locators here. So I'm going to maybe specify this locator to be the origin. Alright, then I'm going to go to the origin set from selection option and click on set from selection. Okay, and then I will go back to aligned again, and this time you notice that the ground level is actually lined up. So we can verify this by switching to another view. We can go to the left view, and then you can see the ground vertices are now lined up. Okay, and well, it's very hard to see. Well, okay, you can see that this is the base grid line. I'm going to switch over to perspective view again, just to confirm that the vertices are actually lined up. All right, so it's a little bit difficult for me to pan because it's very sensitive right now. Okay, but we can see that these points are now lined up with the grid. Okay, so let's go back to the camera view again. So right mouse click here and go back to the camera view. The only thing that you will notice that is a bit off right now is that I'll prefer that the red arrow, which represents the x-axis, this line here, is lined up along this line here. Okay, so this is what I'm going to do. I'm going to go back to the camera tracker. I'm going to switch it back to unaligned again. Okay, and I'm going to turn on the orientation, click and drag, and then just manually rotate this until I get the x-axis to line up parallel to this line, and then the z-axis to line up parallel along this line. Okay, so that looks about right. I'm going to switch it back to align again, and the grid should slowly start to come into place. And right now you can see that it is a little bit tilted. Okay, so that means I have to rotate along the z-axis so that this line is lined up here. So I'm going to switch back to unaligned again, go to z-axis and just rotate this upwards, and I'll switch it back to line again. So I might need to do this back and forth several times. Okay, so the z needs to go up again and go back to align again, and I think I get a pretty close lineup. Okay, so I think this is good enough for me. Okay, and yeah, the lineup looks good. Okay, you can also test it out by creating a 3D shape. Right, so I'm going to create a 3D shape just by clicking here, shape 3D. So now it's not connected to the merge 3D yet, so I'm going to click on the output and drop it on the merge 3D. And the shape, instead of a flat plane, I'm going to change it into a cube. And then I'm going to move this cube up. Okay, go over to the translate tab here, and I'm just going to translate it up about 0.5 units so that it's lined up on the ground. And then the pivot, I'm just going to lower it down minus 0.5 so that when I scale, it will be scaling down and lining up to the floor. So I'm going to reduce it to 0.2. Okay, the purpose of me putting this cube, okay, I'm going to turn on 3D options, showing a bit of lighting so that I can see some shading here. And then I'm just going to test out and see that the lineup is working. Okay, right now my playback is a little bit slow. I'm going to uncheck the high quality and motion blur. I'm going to turn on proxy and auto proxy. Then just going to play back so that my computer can render this a little bit faster. Okay, so one thing to check is to make sure that the cube doesn't slide, because we got a very low error of 0.3. So I think this is a very good, almost a rock solid solve. You don't see that the cube is sliding anywhere. Okay, it's not sinking or anything like that. So it's very important that the bottom of the cube, right, is lined up with the base of this grid. So once you're certain that your lineup is good, the next step we want to do is to export this lineup and then bring it into Maya. So for the output, we are going to connect it to a FBX export. So click on Control Spacebar, type FBX exporter, and then we're going to save it out, give it a name. I'm going to call this walkway track number 3, and then the type will be FBX, and then save. Okay, so once we've done this, once you confirm that you are exporting it out, okay, just to be sure, you have to make sure that you name your file fbx.fbx. This is just to be certain that your file be exported out as a FBX file. Okay, so we are not exporting any lights, so we can uncheck that. We are going to export out the camera. Okay, we're going to reduce constant keys, and then the geometry, I'm just going to export the cube. Now, from my experience, I realized that the scale, whenever I export to the FBX exporter, is very small. So what I'm going to do is I'm going to create a transform 3D. A transform 3D node. And then I want to put it just after the lens distort, and or actually just after the camera tracker. Okay, so shift and put it after the camera tracker, and then the transform, I'm gonna give it a value of maybe 20 in the scale. Okay, so when I increase the scale, notice everything just shrinks down. Okay, you don't have to worry about it because the track information is still intact. Okay, just that everything will become very small. Okay, and then for the cube itself, I think this time I can just increase the size to maybe 10 times. Okay, maybe this is a little bit too big, so I'll bring it down to 5. Okay, now I'm ready to do the FBX export. Okay, so the reason why I put this transform 3D is, from my experience, if I don't put the transform 3D, the resulting scale of the export of the FBX is very small. So this is one way to get around that problem. Okay, so I'm going to export it now. So go to click on the render button, and then start render. So it's going to go through the entire sequence, and it's going to create the FBX file for us. And then we can open up Maya, we can import in the FBX, and then from then on we can start to create our 3D models. So this is a shot that I have already solved before, so I'm just going through the whole process again so that you guys can try to follow along. So the file name is going to be walkway track 3.fbx. And we are done. So click OK. Go over to Maya. I'm going to start a new scene. Then I'm going to import. And then this is how we are going to change our settings to bring in the FBX. So I'm going to bring in export FBX number 3. And if you zoom out, okay, I'm going to zoom out, and you should see the camera and then the cube. And if I scrub the timeline, you can see that the camera has the movement, and it also has the frame that actually contains the image sequence. All right, but this is not textured to the image sequence, so actually for this portion here, we can actually get rid of it. All right, so I'm going to delete this. Okay, and can you see that the scale is much bigger now, because if I go to wireframe, pressing 4, and if you zoom in, I think the grid, okay, where is the grid? Let me see. Okay, the grid is there. Okay, this is the Maya grid. So this scale is actually quite okay. All right, so right now let's look through what the camera is seeing. So click on panels, perspective, and then camera tracker. Okay, and then we are going to bring in the image sequence. So click on view, image plane, import image, and we are going over to the folder that contains the image sequence. Okay, so I'm going to open up the first frame, and then I'm going to click on use image sequence. You'll notice that I'm not seeing anything. I'm not seeing the image sequence. Okay, that is because when you import in the camera, so let me just select the camera quickly again. When we import in the camera, the clipping distance is very short. The far clip distance is very short. So we need to increase this far clip plane. You need to go to the attributes editor of your camera and just increase it to a ridiculous value. I'm going to put at 10,000. So now we can actually see the first frame. All right. So I already activated the image sequence, and everything seems to be moving along just fine. Okay, you notice that the image appears a little bit overexposed. So I'm going to go back to view image, and then image plane attributes, we're already set to use image plane. And right now we need to just change the color space from raw to srgb, okay, so that we get back the look of our image. And also, because we shot at 16:9 aspect ratio, we also need to activate the camera tools, the camera settings, and then turn on overscan, and we get back the, I'm going to press number 6 to turn on the shading again. And this cube, right, if I go over to the material properties, okay, the ambient color is set to a high value. So if I reduce the ambient color, I'll be able to see the shading. So now at this stage, right, you can bring in your 3D models. You can bring in any 3D model, you can put it there. And then basically you can render out your 3D models. So once everything is rendered out, you render it out through this render camera, it should have the exact same motion. Okay, so this is basically how you bring in the file itself. So I'm going to open up the previous file which I done. So basically that's how I set it up. So in this sequence, this is basically the same sequence, but I brought in my 3D model, and also I created a ground plane, and this ground plane I assigned it with AI shadow matte material so that it's able to capture the shadow. So if I click on play for the Arnold viewport, you'll notice that I've set it in such a way that the image plane is invisible, and also the global light, which I'm using, the 360 what do you call that, the sky dome light, which I've used a HDR image, is also hidden as well. So I'm going to show you how to prepare to render your file, or render your 3D object so that it will produce an image looking like this. Alright, so the resulting image that I've got when I render looks like this. Alright, I've got my directional light to cast a shadow, and then if I click on the alpha, so this is what I've got. I've got the shadow matte material on the ground plane to capture the shadow. Alright, and then you'll notice that the background is not visible because I'm not rendering the background. I need to keep this as a separate element. Okay, so I'm going to show you how I turn that off. I'm going to click stop on this first. So if I click on view image plane properties, okay, which is that same image sequence, under your image plane attributes, before you start to do your rendering, under the display mode, in the display mode you click on none, so that the image plane will be invisible when you're about to render. And what about the sky dome light? Okay, for the sky dome, you have to go over to the visibility. Under the camera option, you have to scrub it down to 0 before you do your rendering. Okay, so for the sky dome itself, if you just create a sky dome light, you need to bring in the image. In this case, I've took a HDR or 360-degree image, right, specifically for this area. So it was used to light up my 3D object. Okay, so this is what the image looks like. Okay, so this was the image that was being used. Okay, so this was the walkway. This is the area where that those video clips were shot. Okay, so it was used to illuminate and light this. Okay, so once you're done, you can render. Because I'm using this this is a student version, in order to render, you have to go to rendering, and you have to click on render sequence. Okay, you cannot use the batch render, you have to use the render sequence option. Make sure that you are rendering out through the camera tracker, and then make sure that your render settings is set at Arnold renderer. Now for this demonstration, I have to speed up the rendering, so under Arnold renderer tab, I changed the default from 3:2222 to 2:111. So this will just speed up the rendering. Alright, so if you got a lot of time, or if you have a very fast computer, you can just leave it at default. And of course, you also want to make sure you're rendering it as a sequence, okay, from frame 0 to 250, and then we're gonna render at full HD, which is the original resolution of the backplate. So I already rendered the sequence, and I'm going to show you what it looks like. So let me just go back to the original. This is the original, and I actually brought in the 3D model itself from here. So let me just remove the model first. So this was actually the soft track. Okay, it's actually very similar to the demonstration that I did. Okay, this time I want to bring in the 3D rendered sequence. So I'm going to click on the loader. I already have the 3D elements rendered, and I'm just going to show you what they look like. So this is the rendered sequence. Okay, you can see it's a little bit dark, but not a problem. We can later add in a color corrector to it, or a brightness and contrast adjustment. So now we have the 3D element. We just want to put it on top of our plate. So just drag this output, and then click on the output of the original clip, and then we have merged it out. I'm going to disconnect it, and then I'm going to look through this merge. Now this is a different type of merge. This is a 2D merge, and this is a 3D merge. So I want to view the results of the merge, so I'm going to drag it and drop it over here. Okay, you can also press number 2. It will give you the same result. So you can see that now because of the lineup, everything is matching properly. Of course, our plane is looking a little bit dark, so we can fix that by applying a color corrector, or I'm just going to put a brightness and contrast between the walkway. So go between the 3D element, which in this case is this vertical takeoff helicopter, and now I'm just going to bring up the gain. Okay, then just bring out the brightness. Okay, the brightness is affecting the back, so I don't want to do that. Okay, so I'm going to enable this pre-divide post divide now multiply, so it doesn't affect the background. Okay, so now you can see that the aircraft is a little bit brighter, and that is how you bring in a 3D element from Maya with the exported 3D match information. Okay, so once we are ready, okay, just going to put this aside, and basically we can just output this into a render. Okay, I'm going to put a saver, and I'm just going to save it as a QuickTime movie. Then .mov, then click save. Alright, so I'm going to connect this, and then let's take a look. Okay, so this will be the output result. So once you're ready, you can just click on save. So I'm just going to check the settings very quickly, just make sure that I'm rendering out at H.264. Alright, and then you can hit render. So this is just a very simple composite. So because the rendering of the 3D elements from Maya is going to take a long time, so I'm not, for the sake of time, I'm not going to demonstrate that in this tutorial. So right now you can see that I'm now combining the 3D elements with the original plate. Now of course the shadows need to be worked a little bit better, because if you have more time, you can actually create a shape to match this brick section here, so that the shadows will actually form all over, will actually deform correctly or project correctly onto this surface. Okay, so once it's done, I should be able to see the movie out. Okay, it's over here, and then let's check out the movie. And there you go. So that is the entire process of creating a match move, okay, and then exporting it to Maya, and then from Maya rendering it out, and then bringing out the EXR render elements back into Fusion again. Okay, so yeah, that's the entire sequence. Hope you can follow this and try this out on your own. Now, before I end this video, I just want to talk about another type of 3D tracking solve, which is the nodal solve. Okay, so for this particular shot here, okay, which I've already solved. Now, the camera tracker in Fusion, right, is specifically, I'll classify this as a very general tracker because it will try to track anything and everything, okay, and it's trying to get its best guess. So it's not like a dedicated tracker like SynthEyes or PFTrack or 3D Equalizer, where you can actually tell the tracker itself during the solve that, okay, this is a tripod shot. Okay, when I took this shot, this is actually a shot on a tripod. Okay, so it actually took some time or some tweaks, right, in order to get this to work. Okay, because in my first solve, right, the camera is like moving all over the place, right, and if you zoom in closer to the camera, the trajectory, you can see that the camera is actually moving quite a bit as well. Okay, so it's still quite okay. The end result of this solve, the error is let's see, it's about 0.49, which is actually not too bad as well. However, for nodal solves, okay, so this is more for my class students. For nodal solve, you have to be aware that these dots, right, do not represent the true 3D space, right? It doesn't represent the solved 3D space, because for nodal cameras or for panning cameras like that, it is impossible to tell the depth of the shot. Okay, so what you basically get is like a bunch of points, right, that's projected on the inner side of a sphere, if you think of it that way. Okay, so it'll be, if your solve is good, right, if you put anything that is in front of the camera, generally it will still stay quite locked. Okay, or another way is if you can put the object as close to the tracker as possible, because the tracker points, the solve points or the locators are pretty much locked down. Okay, so I will possibly create another tutorial showing you guys how I solve this. Okay, but meanwhile, okay, if you can, try to do this on your own. Okay, hope you find this video useful, and give this a shot, right?